go. This is Tech Math 2. And we're in section 8.3 and 8.4 today, which have to do with simplifying radicals. So we're going to take square roots and cube roots and fourth roots and end up making whatever it is, simplifying them to be simpler than what they are. All right, so we have some rules. And so we're simplifying square root quantities. The first rule is the quantity under the contains no perfect squares. So that guy there has no perfect squares. No. Now, that's all in English, right? So 4 would be a perfect square because it's 2 squared, right? And 6 would not be a perfect square. 8 would not be a perfect square. 16 would be 4 squared. 32 wouldn't be a perfect square, but 64 would be 8 squared. All right, so that's what we mean by perfect squared. The radicand contains no fractions. The radicand. Now, who made up that word, radicand? I mean, really. So the thing inside the radical is the radicand. So this thing here is the radicand. I won't spell it because no one's going to ask you to spell it. But anyway, I can't have a fractional square root guy. I gotta rationalize the denominator and call that the square root of 2 over 2. So I can't write it that way. I have to write it that way. So that's what rule number 2 is saying. The denominator of a fraction contains no radicals, so rule 3 is the same as rule 2, just said a different way. All right, so that those are things, and then we have we have another set of rules that say if I have the square root of AB, then that's the same as the square root of A times the square root of B. And if I have the square root of A over B, that may or may not be the same as the square root of A over the square root of B, depending on whether or not B is 0. So as long as B isn't 0, then I can do that. But if B is 0, then I can't do that. And those same rules are done again on page 287 for third roots, and then on page 289 again for nth root of stuff. All right, so we'll look at problem number 1. And we get the square root of 49. And we, oh gee, that's 7 squared, so that's a perfect square, so this is going to be 7. We can think of that as 7 squared to the 1/2, which gives me 7, but I don't necessarily have to think about it that way. Okay, we'll look at number 3. And number 3, square root of 75. And we use our massive math skills to recognize that's 3 times 5 squared, and that the 5 squared is a perfect square. It can't stay under there, so this would be 5 to the square root of 3, and I will be done. Now, your calculator, which I didn't bring with me, probably will do that for you. If you go square root of 75 and you're in math print, it should probably give you 5 to the square root of 3, does it? I think it does, but my wife is giving me this stupid shirt that doesn't have a pocket, and without a pocket I can't, yeah, it does. Okay, so your calculator will do that for you directly. So that's always a good thing. We'll look at number 6 next. And we have the square root of 96, and I say, well, what am I going to do about that? Well, again, I could just put it in my calculator. It's going to tell me the right answer. But this is 2 times 48, and 2 times 24, and 2 times 12, and 2 times 6 and 2 times 3. So there's a perfect square and there's a perfect square. So it's going to be a square root of 4 squared times 6, which is going to be 4 to the square root of 6. Which is probably what my calculator told me to do. Okay, moving on to 16. I have square root of 5 over 16. I recognize 16. I can rewrite it as square root of 5 divided by the square root of 16. I recognize the square root of 16 as 4 squared. So I can rewrite that as the square root of 5 over 4. And that would be a reasonable thing to do. We'll go down to 29. I have the cube root of 125. I recognize 125 as 5 cubed, and I write down my answer as 5. Moving down to number 38. I have the cube root of 72x to the 4th y to the 6th z squared. Okay, so now what is 72? 72 is 2 times 36, which is 2 times 18, which is 2 times 9, which is 3 times 3. All right, so I've got the cube root of 2 cubed times 9 times x cubed times y squared cubed times z squared. And then I bring out all my perfect cubes. So I got a 2, I've got an x, I got a y squared, and then left over cube root of 9xz squared, and I'm all done. Now, my calculator is not going to do that. It's only going to do numeric things. So but if you had a TI 86, 87, 89, it would do that directly. It would just tell you what that answer is. I have days like that, I know. We'll go to 47. It does do that? No, I don't think so. All right, so I got the cube root of 4a over 50 b squared. All right, we got to make this look more like an A. No, not really. Well, 4 is not a perfect cube. A is not a perfect cube. Neither is b squared. Neither is 50. So I'm sort of hosed on all that. But I've got a radical in the denominator, which I'm not allowed to have. So this is the cube root of 4a over the cube root of 2 times 5 squared b squared. And we want to rationalize the denominator. So this is going to be multiplied by the cube root of what? Well, I have 1, 2, so I'm going to need 2 more. I have 2, 5, so I'm going to need 1 more. And I've got a b squared, I'm going to need another b. 4 times 5 times b. And so now we got, on the top, I have the cube root of 2 times 2a, 2 times 2 times 5b, and on the bottom I've got a 2 times 5, 2 times 5, 2 times 5b. Okay, and then I got 1, 2, 3 of those guys, so I can bring one out. 2 cube root of 10 AB divided by 2 times 5B I can get rid of the 2's. And now I'm ready to write down a final answer. Final answer, cube root 10ab divided by 5b. Well, that seems like too much work for 1 point on a test, right? Yeah, pretty much. All right, so we'll go down to 54 next. Fourth root of 162a8. All right, so I'm looking at 162. Again, I think, well, no, your calculator is not going to do that for you because you have this a sitting here. So 162 would be 2 times 81, which is 9 times 9, which is 3 to the 4th. Okay, so I got the fourth root of 2 times 3 to the 4th, a squared to the 4th. And now I can write down my final answer, 2a squared, no, 3a squared. 3a squared, fourth root of 2. Really? Yeah. 4a squared, fourth root of 2. All right. Okay, moving down to 72 before we go to the next glorious section of the book. Number 72. Cube root of 27, which we know is 3 cubed, times a squared plus b cubed cubed. All right, well, that's just 3 times a squared plus b cubed, and I'm done. All right, well, that was okay. All right, now we're going to add, subtract radicals. Add and subtract radicals. That seems like a good idea. And so we're probably going to have to simplify them first. If I had 5a plus 7b, can I simplify that? No, I can't. But if I had 5a plus 7a, I could say that that's 12a, right? So I'm doing the same thing. My radicals have to be the same guy in order for me to add them. All right. So looking at number 1, 3 the square root of 2 minus 5 the square root of 2 plus the square root of 2. So I'm looking at that and saying, well, you know, this is the same as 3a minus 5a plus a, which is going to be minus a. So this is just going to be minus the square root of 2. So I got 3 of them, minus 5 of them gives me minus 2 of them, plus 1 gives me a minus 1 of them. So there's no difference between that and this, like conceptually when I'm thinking about it. All right, I'm going to go down to number 3. Square root of 8 minus the square root of 2. And I said, well, gee, that doesn't look like they're the same to me. But I can say that this is 2 times 2 squared minus the square root of 2. And then that becomes 2 square root of 2 minus square root of 2. And now I just have the square root of 2. So in your calculator, you could have put in square root of 8 minus square root of 2. It's going to give you the square root of 2 back. So I'd run to the calculator. Does it do that? Did you try it, Wyatt?
That's not square root of 2.
Yeah, exactly. So it'll do that for you. All right, now let's see. That guy's about the same. Yeah, we'll do 4. So until they throw in a variable, your calculator is going to do it for you anyway. Square root of 3 minus 3 the square root of 3 is minus 2 the square root of 3. All right, well, that seems okay. Moving down to 12. 4 the square root of 50. 5 the square root of 72. 3 the square root of 8. Well, 4 the square root of 50, that's 2 times 5 squared, so that'd be 20 square root of 2 minus 72 is 8 times 9, right? 8 times 9, so that's 5 the square root of 2 times 4 times 9 plus 3 the square root of 2 times 4. All right, well, and I would have done all that in my head anyway. So I got 20 the square root of 2 minus 30 the square root of 2 plus 6 the square root of 2. 2 times 3 is 6. 30. Okay, so that looks like minus 4 the square root of 2. Okay, we're going to do 13 next. Number 13. And if I would have brought my calculator, I'd just put it in my calculator. So I've got, what do I got? I've got 9 the square root of 3 minus 9 the square root of 48. I have to figure that one out. I can't do it in my head. Plus 5 the square root of 3. All right, so I look at 48. That's 2 times 24, that's 2 times 12, that's 2 times 6, that's 2 times 3. All right, so I'm going to have 9 the square root of 3 minus 4 times 9, 36. 36 the square root of 3 plus 5 the square root of 3, and I'm going to have I don't know, minus 30, minus 22, minus 22 the square root of 3. Is that what I got? Yeah, okay. Okay, we'll move down to number, oh yeah, that'd be good, number 30. Number 30. Cube root of 48. Minus 2, the cube root of 162, plus the cube root of 750. Okay, well, I don't know. Let's say it's 48. That'd be 2 times 24, 2 times 12, 2 times 6, 2 times 3. So it looks like 2 the cube root of 6 minus 162. So that's 2 times 81, which would be 3 to the 4th. Okay, so that'd be 6 square root of the cube root of 3 times 6. All right, and then so that's 10 times 75, which is 2 times 5 times 3 times 5 times 5. So this is going to be 5, the cube root of 6. Okay, well, isn't that convenient? Everything is a cube root of 6. 5, 7 minus 6. The answer, cube root of 6. Does your calculator do that one? Watching how I was doing it? Okay. It might just do that one. I don't know. I don't see why not. Okay, 38 is next. All right, so I've got a 38 square root of 6 over 2 plus 1 over the square root of 6. So I got two issues here. I need a common denominator, and I need to rationalize my denominator. So first thing I'm going to do is rationalize my denominator. 6 over square root of 6. So I got square root of 6 over 2 plus square root of 6 over 6. And then I multiply this guy 3 over 3. and I'd add 4 the square root of 6 over 6. And then I'd say, well, 2 goes into both of those, so my final answer would be 2 over 3 square root of 6. So that's how I would do that one. Anything else cool here? Okay, 39. We'll go to 30. We'll go to 30. I just did 38. All right, so I'll go to 40. Q square root of 1 over 3. Square root of 3 over 3 minus the square root of 12 over 6. All right, so I got 1 over the square root of 3. I've got square root of 3 over 3. And I've got 2 the square root of 3 over 6. And that's not a equal sign, that's a minus sign. All right, I need to rationalize the denominator. Multiply top and bottom by square root of 3. Square root of 3 over 3 plus the square root of 3 over 3 minus the square root of 3 over 3. Can I say the square root of 3 over 3 4 times in a row and with a straight face? Yeah, I like that. Okay, so square root of 3 over 3 is my final answer. Okay, we'll do 45. Oh, anybody got a good joke to tell? I'm almost done, and we have 20 minutes to go. You know, we're gonna have to come up with something. You know, whatever. All right. You know, I'll turn off the recording. Okay. All right, that's what we'll do. Control Alt.
That's the latest.
Now we're back live again after that reprise, and I'm going to do number 44. And I got 2, the cube root of 2, plus 5, the cube root of 2 squared. And that's supposed to be a cube there, I just know it. All right, so that's what that is. So I'm going to rationalize my denominator first. Cube root of 2 divided by the cube root of 2. And I'm going to end up with 2, the cube root of 2, plus 5 over 2, the cube root of 2. And then I'm going to say that this is 4 halves plus 5 halves. That gives me 9 halves the cube root of 2. All right, so that worked out pretty good. And then we'll go to 45. And so I got the cube root of 3 over 4 minus the cube root of 2 over 9 minus 1 over the cube root of 6. Well, at least I wrote the problem right. Okay, so I got the cube root of 3 divided by the cube root of 2 squared. And I'm going to have to rationalize that denominator, so I'm going to multiply by the cube root of 2 divided by the cube root of 2. And then I've got minus the cube root of 2 divided by the cube root of 3 squared. So I'm going to rationalize that denominator by the cube root of 3 over the cube root of 3. And then I've got minus 1 over the cube root of 6. So I'm going to have to rationalize that. Cube root of 6 squared over the cube root of 6 squared. All right. Is that okay? So now I've got, on the bottom I got a 2. And then the top I got the cube root of 6. And then I got minus I got cube root of 6, and on the bottom I have 3, and then over here I've got minus the cube root of 6 squared divided by 6. Did I write the problem down right? Yeah, I'm afraid I did. All right. Well, this is cube root. Cube root over 2, cube root over 3. So I need a I need a common denominator. All right, so my common denominator is 6. So I'm going to have cube root of 6 over 6, and I'm going to need 3 of them, minus 2, the cube root of 6 over 6, and I need 2 of them, minus the cube root of 36 over 6. All right, I think I'm okay. So I've got the square cube root of 6 over 6, the whole thing over 6, and the cube root of minus cube root of 36. All right, so now I'm done. Now, if you were to give me a number, like 1.78 or something like that, and that happened to be correct, I would count that right too. Okay, in this particular thing, we're not doing that, but that'd be perfectly okay. Okay, we'll do 2 more and then head for the door. Number 55. Okay, we got the cube root of A over the cube root of B squared. I'm going to want to rationalize that denominator, so I'm going to take cube root of B divided by the cube root of B so I can have it rationalized. I'm going to have plus the cube root of B divided by the cube root of A squared. And I'm going to want to rationalize that denominator, so I'm going to take the cube root of A divided by the cube root of A. And then I've got minus 1 over the cube root of A squared B squared, and I'm going to want to rationalize that denominator, so I'm going to take the cube root of AB over the cube root of AB. Right, so that's my plan. I'm sticking with it. And on the bottom I got a B, and on the bottom I've got an A, and on the bottom I've got an AB. So that looks good. And on the top I've got cube root of AB, I got cube root of AB, and I've got cube root of AB. Okay, well, that looks good. Now I need a common denominator, so I can multiply both top and bottom of this guy by A, top and bottom of this guy by B. Okay, and now I've got a common denominator, that is AB. And, okay, how about A plus B minus 1 quantity cube root of AB. Okay, looking good? Yep. And your calculator is not going to do that. The TI 86, 80, 87, 89 will do that if you happen to have it. TI 84 is meant for 8th grade people, so it's not going to do that. All right, one more. And we need to pick one that we can't get done before the end of the hour, so we'll pick 56 because that's the last one we have. Okay, so I've got the cube root of A squared B over 3 squared. I'm going to want to rationalize that denominator, so I'm going to go cube root of 3 over cube root of 3. All right, and then I've got minus the cube root of 3 A squared over B. Okay, and I'm going to run a rationalize that denominator, so I'm going to take the cube root of b squared over the cube root of b squared. Then I've got plus the cube root of 3b over a, and we're going to want to rationalize that denominator, so we'll go cube root. Oh, that was pretty silly. Let's be consistent. So we'll go cube root of a squared over cube root of a squared. And then I've got, what do I got? I got minus. Now, 24 is 8 times 3, right? So that's 2a b squared square root of 3 a squared b squared a squared b squared. That won't work. A squared b right. This is b cubed, and it's just a squared b. Right, so there's 3 plus 2 is 5, 9. This is cube root, right? Cube root. So I was right the first time. That's a 2 there. Okay. Well, that certainly was a lot of ink. So I've got cube root of 3 a squared b over 3 minus 3 the cube root of 3a squared b squared over b plus the cube root of 3a squared b over a minus 2ab squared cube root 3a squared b. Well, that certainly is inconvenient. All right, but that's what I have. And we'll throw a line in here so that we remember that that guy belongs to the guy on top. All right, so now we have a common denominator, 3ab. Okay, so my common denominator is 3ab. So this guy's got to be ab cube root of 3a squared b minus 3a cube root of 3a squared b squared plus 3b square root cube root of 3a squared b minus 6 b cube root of 3a squared b. Okay, so I've got oh, there's a 3a squared b, here's a 3a squared b, there's a 3a squared b, and that guy there doesn't count. Alright, so I'm going to bring the 3a squared b's together. Okay, so I got ab minus 2b, 3b, minus 3b, minus 6b. So I can make that a 9b, right? Minus 9b times cube root of 3a squared b minus 3a cube root of 3a squared b squared divided by 3ab, and nothing cancels out, and that's the end of the problem. And isn't life wonderful? Now, we still have a minute left, so let's see if Maple will come up with the same answer. I'm not sure I can put it in Maple that quick. But it doesn't matter. You guys don't have anything to do. We can run over, right? Yeah. So we're gonna put this problem in Maple and see what Maple thinks about it. And again, for all of $124, even you could have a Maple. All right, so I got a parentheses. I got an a squared times b divided by 9 raised to the 1/3. I probably don't need to put parentheses around the 1/3. And then I've got minus, well, I probably have a cube root thing over here, don't I? Yeah, minus cube root of 2 times a squared divided by b squared. And then I've got plus cube root of 3b divided by a. And then I've got minus, way to go, minus cube root of 24 times a to the 5th. I'm putting it in the wrong spot. Right there. 24 times a to the 5th times b to the 7th. B to the 7th. So is the problem in right? Boom. All right. So isn't that lovely? That's not exactly what I had. Let's see. Did we go simplify? S-I-M-P-L-I-F-Y. Simplify. The guy up above. Oh, I misspelled simplify. I'd spell simplify correct. P-L-I-F-Y. Well, thank you very much. I still have it misspelled. It's misspelled down below, but it's not misspelled up above. S-I-M-P-L-I-F-Y. Parentheses. It's still doing it. Stupid thing. All right, so there we go. Try it again. S-I-M-P-L-I-F-Y. Why is it doing that? Why is it misspelling? Why can't it simplify something like that? Spell simplify right. S-I-M-P-L-I-F-Y. Okay, simplify expression. Okay. So I'm spelling it right, and it can simplify those things. Combine, convert, expand, factor, normalize, simplify using the gamma function, simplify using polar form, simplify radical. There we go. Simplify radical. Copy. I'll put it here. Paste. Did it just do the same thing? All right. Oh. This is getting more and more interesting. You notice that? Notice the 23. Notice I go from the cube root of 24 to the cube root of 23. Tell me how that happened. How could Maple possibly do that?
Yeah, 1/3.
Is this the guy messing it up? So you want me to rewrite the first guy? Okay. So I'm going to rewrite the first guy. All right. I'm going to rewrite the first guy. Right here. I'm going to go and put in third root of. And I'm going to have a squared times b divided by 9. No, that goes there. And then we're going to get rid of all these guys. Okay, now I got multiply signs every place. Okay, I'm going to go to that. Huh? Yeah, great. Isn't that lovely? That is so wonderful. Okay, going to do one more thing. I'm going to go in and take this, copy, and we're going to put it in front of here. Paste. All right. Delete. Delete. I'm going to give these guys one more chance. One more chance. 1,000 mathematicians gives you, Maple gives you the power of 1,000 mathematicians, and it does the same thing. It's putting a 23 there. I don't believe it. Yeah, exactly. Yeah. Well, I didn't do that, but well, the only thing we have to do is say thank you, Maple, right? All right. All right. So
like that.
Huh?
There's like a space between the 2 and 3. I feel like
Yeah, there is. That's 2 times. You're right. That's 2 times the cube root of 3. So yeah, I guess that's right. Yeah, it's not really a 23. It's really, yeah, you're right. You're absolutely right. Except it still isn't doing what we want it to. I wonder how we kind of anyway, that's for another day. I guess we have to quit now because the next your next instructor thinks he wants the room. So
birthday, he doesn't have to like.
yeah.